Suddenly, the search for life pauses as the fight for survival resumes. Mission Control signals that a high-risk solar flare is headed for Mars.
A solar flare is a tremendous outburst from a relatively small region of the sun. A huge amount of energy goes pouring out explosively, and a bunch of energetic charged particles go zooming through the solar system. They can interact with cells and harm them. Also, high-energy electromagnetic radiation, like X-rays, gets produced, and those can harm us as well. So it's wham, and then wham again sometime later.
Earth's magnetic field shields us from the worst effects of solar flares. But Mars lost its magnetic field 4 billion years ago.
After a solar flare is seen by people on Earth, we want to warn the astronauts on Mars. Now, we can't warn them about the electromagnetic flash because our warning signal would travel at the same speed as that flash from the sun. But we can warn them about the onslaught of charged particles. The high-energy charged particles can travel perhaps at half the speed of light.
The HAB has a radiation-proof chamber, but it's now too far away. While the astronauts' spacesuits shielded them from the solar flare's X-rays, they have only minutes to seek shelter before the flare's high-energy second wave slams into Mars. If a future human mission to Mars crash lands, the astronauts will have to contend with even more than the harsh Martian landscape. A solar flare of charged protons would be far more dangerous here than on Earth.
Well, Mars doesn't have a magnetic field like the Earth does, so all of these high energetic particles and these charged particles would be hitting the surface directly and hitting any astronauts that we had on the surface. They would not be protected from all of these dangerous rays and these dangerous particles, whereas on Earth, we're comfortably protected by our magnetic field. There are a number of bad effects that would come about from the energetic particles hitting an astronaut on the surface. Increased rates of cancer, for example, or other diseases, radiation sickness and radiation poisoning.
In fact, astronauts aboard the space station have occasionally been told to hide in special chambers that protect them against the charged particles and radiation coming from a solar flare.
For the astronauts in the middle of the Valles Marineris, the only shelter is their pressurized rover. The rover's primary radiation shielding isn't lead, it's the food packets lining the walls, along with the astronauts' own waste material.
Feces contain hydrocarbons, and hydrocarbons contain hydrogen, and hydrogen is a very good absorber of radiation. Hydrogen that you have in the form of food before it's consumed will help shield you from some portion of this radiation. And certainly once you've consumed the food, you want to put your feces in these little sealable Ziplocs and back on the wall of your vehicle to shield you from radiation.
If you're going to survive in space, almost nothing can go to waste. Not even waste.